First, I would like to introduce Tony, if he would like to come up. He'll start off talking on his topic. Thank you, Tony. We'll take questions at the end if that's okay, although if anyone has anything specific, maybe interrupt between the discussions. Okay, thank you.
Good morning, everyone. It's a great pleasure to be here with you today. This is my first trip to Dubai. It's a fascinating country, and I'm greatly enjoying my trip here. Looking forward to meeting most of you during the next couple of days. I'd also like to thank the organizers for inviting me to participate. As Alistair mentioned, my specialty is patent analytics, and in particular, my company does patent landscape reports. And as he was mentioning, the field of patent analytics is critical for technical decision making, and that's the primary use of the reports I generate. My clients are, generally speaking, Fortune 500 type companies, but also international organizations who are interested in making sure that they understand as clearly as possible what the technology landscape is before they begin to make decisions about the directions that they go with their own R&D programs and the investments that they're making in patenting their own technologies. So understanding what the competitive landscape looks like and what technology is developing, what your options are, is critically important to lower your risk and to make the best decisions possible when it comes time to set your own IP strategy and your own technical strategy. And patent landscape reports are an outstanding way to do that. Now, what I'm going to focus on, what you see here, it says visual insights from patent data. And I'm actually one of those guys who's sort of, people make too much, generally, out of the visualizations in and of themselves. They see the pretty picture and believe that the insights are just going to flow from the picture without any sort of input or any sort of understanding of what's going on in the background. That can be a little bit dangerous. There's a great deal of effort that goes into developing the database, or excuse me, the collection, the data set that's used to subsequently generate these visualizations. So while the focus of the talk is going to be on visualizations, I want to start by saying that probably about 40 to 60% of all the time that goes into any individual project is actually spent developing the database or developing the data collection. That's by doing a patent search, and then also by doing standardization of the data and cleaning up of the data and categorization of the data, because it's really that pre-processing of the data that makes the visualizations that much more impactful, insightful, and useful. So having said that, I'll go ahead and start. Now, this is probably the most maligned of the patent visualizations. I refer to these as spatial concept maps. Most of you will probably recognize something like this as a themescape map. Themescape is a trademark of Clarivate and a very good product. So this is not an endorsement of one product or another, generally speaking. But I like to talk more generally. One of the things that I did a few years ago, by the by, for those of you who are interested in learning more about patent analytics, is I generated a document for WIPO called the Preparation of Patent Landscape Reports. And in that 150-page document, I go through step by step how to generate patent landscapes, starting with the search and going through the various standardization and cleanup steps, and then finally a brief word about a lot of the visualizations, and then building the actual report itself. And so in order to start talking about this particular visualization, I came up with the term spatial concept maps. Now, these types of visualizations are most useful to provide a means of comparison. So for instance, this one, my company recently did a report on quantum computing. And so I just want to make sure I've got the right, yeah. So these are the top companies in quantum computing, basically based on what the media says. D-Wave has been around for years. They've been doing this longer than just about anybody else. But IBM, our analysis showed, it will actually have more quantum computing patents than anybody in the world in 2017 as far as publications are concerned. They've put in a huge effort, and they're basically off the chart to some degree with regards to their interest in this particular area. But then also Microsoft and Google. And what this map clearly shows you, we've divided this up into qubit technology, which is the underlying architecture for using a quantum computer. It involves the use of qubits. And there's various types. There's quantum dot, ion trap, diamond vacancies, superconducting loops, and topological. And so this shows you quite clearly, for instance, that Microsoft has a very strong position in topological qubits, whereby D-Wave and IBM, and to some degree Microsoft also as well, the vast majority of the patents in this particular area happen to be actually in the superconducting loops portion. But then you also have the hardware here, waveguides, quantum bit hardware, calculations, circuits, processors, photon generation, and then some of the applications. In a subsequent report, we looked specifically at quantum cryptology and quantum communication, and then we've generated a third report that brings the entire collection together into what we call quantum information technology. But this map, because the underlying contours and the map here stays the same, but then you can use colored dots to show different organizations, for instance, and start making comparisons to what the different organizations are interested in. So that's a spatial concept map. There we go. All right, and this next one, we call this a spark chart, which is a name one of my clients came up with. And this is a very, very powerful chart, very busy. Don't expect you to be able to necessarily read all the details of this. This is a chart that you would literally spend hours on, theoretically, because it's got a great deal of information. It starts off here on the left side with grants versus applications for each of the major players. So the bar here shows how much of it is granted versus how much is it still pending. Then the spark line, which is where the spark chart comes from, shows you this specific row and the trend over time within that particular row. So it's better than a heat map in a sense because it's row specific and it shows you exactly what trend that individual assignee is doing. And then you've actually got the raw data itself that we've highlighted that, for instance, Toshiba has done a great deal in this area recently. There's that IBM number that I told you about, 60 publications in the field of quantum computing in 2017 alone. And then also here, Microsoft with 21 and D-Wave with 29. So again, this particular chart, we believe that individual visualizations sometimes can, without context, don't have as much meaning. So it's always very important that you add additional context so that you get the real gist of what's going on. Next slide. This is more of the same, but it's interesting, the emergence of some Chinese companies. This is actually, these two particular slides are for the entire quantum information technology field, not just quantum computers all by themselves. And as I said, this Szechuan Quantum here, with 55 publications in 2017, is making, that's a huge investment, and rivals IBM in this size. And they're the second largest for 2017. They dropped down into the about 15th place overall, but looking just specifically at 2017, they would be number 2. So again, that's why when we do this sort of chart, we try to add some context so you can get some additional information rather than just who's got the biggest number, but how is that number broken up into applications versus grants and so on. What we also do is we also break these down into various categories. And so in this particular case, the categories are application versus hardware versus qubit. And so you can start to see very clearly the difference between, say, a Japanese company, which is more primarily interested in applications, and then secondly in hardware, and finally qubit, not quite so much in qubit. Meanwhile, with D-Wave systems and IBM, you see that it's reversed. So the overall trend that we saw in this particular field, this quantum information technology field, is that North American companies will likely control the computing devices, and it will be Asian companies that are likely to determine how those devices are going to be used, the primary applications being cryptology and communications. And this is just a similar slide that shows a different set of companies But again, following that same trend, Microsoft bucks it a little bit here with a little bit more in hardware than Qubit. But again, we see here Magic Technologies is the almost single example of a U.S. organization. But the interesting thing about them is they stopped patenting in this field 5 years ago. So it makes for a very interesting speculation as to what their current interest is. And then I wanted to make sure I put the Chinese companies up here as well. So you can see the overwhelming reliance or interest in those applications as opposed to devices themselves. This is a sunburst diagram. These can be very, very powerful. They're similar to a column chart, but it's a different way of looking at the information. And so, for instance, in this case, we're looking at the different types of categories around the outside here, and then we are looking at some of the details within the outer ring. And this one's an even a little bit better example where we took, here we go, two companies that we think are quite similar to one another. This showed up in the spatial concept map. You've got IBM here, Northrop Grumman here, and then we start looking at hardware versus Qubit versus application. And you notice even in the second ring, the relative distribution of those three categories are very similar between IBM and Northrop Grumman. And then when you start to look up in here, let's say a Qubit, for instance, you've got superconducting loops and superconducting loops as the primary areas of interest. And then hardware as well, you can start to make comparisons between them. So these sunburst charts do a very good job of making more specific comparisons. And finally, this will be my last slide. This is what we're calling a patent citation network map. This is a map of a portion of the quantum field again. And the interesting thing about this was that Northrop Grumman, for instance, and HP didn't necessarily show up in our list of top assignees. They don't have the largest portfolios, but they have some of the most well-connected ones. All of these lines are based on forward citations and subsequent backward citations within the collection. And so the most well-connected and largest spheres here are those organizations that are the most influential based on patent citations. And instead of looking at a hyperbolic tree, for instance, which would look at one patent at a time, this is looking at thousands of patents simultaneously and reducing all those families down into the corresponding companies that are associated with them, and then showing the linkages because the families are being cited by one another within that collection. And so what emerges is companies like Northrop Grumman being much more important than their size, their portfolio size would indicate. And the same thing with HP. And we've actually made several of these for the various collections or various reports we've done on quantum computing. And they provide some additional insight. We identified Raytheon from one of these diagrams, for instance, as a really key player in the overall quantum information technology space. Meanwhile, they have a relatively small portfolio of about 35 documents compared to hundreds for IBM and D-Wave, for instance. So they don't show up in the top 20, top 25 even. But when you start looking at influence based on citations, Raytheon bubbles up to the top. So with that, one last visualization. We can also summarize these things. We've started doing something that we call a patent stat sheet, where we take relevant information and put it all together on one page. They give some analysis, a company overview. Citation map might go up here, for instance. One of these sunbursts about the company's activity, how much of their portfolio is organic, so how much of it is acquired versus owned by them, and then their top inventors, how many top inventors are still with the company, and various information. We can put anything there that anybody would like, depending on what it is that they'd like to summarize and hand out in a meeting to decision makers, for instance. So instead of just giving somebody a 25 slide PowerPoint deck, you'd give them a stat sheet, and they would have all the relevant information in one place. So with that, thank you very much for your attention. I look forward to speaking to you folks during the rest of the week. Thanks very much.